All right, so for these examples, we're going to convert each expression into an equivalent rational expression with the LCD, or the least common denominator, as the denominator. Okay, so first we're going to have to find the least common denominator, right? So here between 9x y and 15x z, we want to find the LCD, right? And so we're going to use the same process. And so 9 is 3 squared, right? 3 times 3. And then we have xy. And then 15 is 3 times 5, xz. Okay, so those are our lists, right? And so I want to take everything I need from those lists, but not with any excess, right? So here I'm going to, since I have 3's that match up, I'm just going to take the one with the highest exponent. That'll cover what I need. So I have 3 squared. Okay, and then with the x's, we have an x here and an x here. Or actually, let me get the 5 first. So we just have 1 5, so I'm just going to multiply here by 5. So we need that. And then with the x's, they both have x to the first power, so we're just going to put an x there. And then with the y's, we have a y here and a y, or no, we don't have another y. So we just bring the y over. And the same with the z, right? So if they don't have a match, you just bring them down as they are. If they do have a match, you take the one with the highest exponent, okay? So now I'm going to just multiply all this together. So 3 squared is 9 times 5 is 45. Then I'm going to have x, y, z. So that's the LCD, okay? So now I need to get these both to have that same denominator. So let's start with the 4 over 9xy. So what do I need? What's missing? Well, what times 9 equals 45? Let's try to be 5. And then I have an xy here, right? But I need a z. And so I'm going to multiply by z as well. So I'm going to multiply by 5z on the bottom, and that'll get me this. But if I do that to the bottom, I want to do the same thing to the top, right? So I'm going to multiply by 5z on top as well. And so what I'll end up with is 4 times 5z on top is 20z. And on the bottom, 5 times 9 is 45. And then I'll have x, y, z. All right, so that's the equivalent to this one here. We got that one covered. Let's do the same thing with 2 over 15xz. So let's figure out what we need to multiply here. So 45 divided by 15 is 3. So I'm going to multiply by 3. And then let's see, we have an x and a z, but we don't have a y. So I need to multiply by 3y. So I'm going to do the same thing on top. So 2 times 3y is 6y. And then on the bottom, I should get 45xyz, right? That's the whole reason we're doing this, is to get these to match up. And sure enough, if I multiply 15 times 3, I get 45. Xz times y is xyz, okay? So these are equivalent expressions here. All right, same thing with number 10. So first we're going to find the LCD. So I'm going to rewrite these 2 times 3 times x squared. 8 is 2 to the third power, x cubed y. And 4 is 2 squared y squared, right? And so I want to take out everything I need without excess, right? So I see I have a bunch of 2's matching up. I want to take the one with the highest exponent. And then I have a 3 all by itself, so I'm going to take the 3. We have a couple x's, so I want to take the one with the highest exponent, so it's going to be x cubed. And we have a couple y's, so I'm going to take the one with the highest exponent, so it'll be y squared. So when I multiply those together, 2 cubed is 8, times 3 is 24, and then we just bring down the x cubed and the y squared. So that's our LCD. Okay, so now we need to make all of these have that same LCD, right? So let's think about it. What can I multiply by 6x squared to make it into 24x cubed y, right? So let's write that down over here. And so what times 6 equals 24? 4, right? So I'm going to multiply this by 4. And I have an x squared, but I need an x cubed, so I need one more x, right? And then I also need a y squared. Okay, and whatever I do to the bottom, I'm going to do the same thing to the top. And so when I multiply 4 times 5 on top, I get 20. bring over the xy squared. On the bottom, 6 times 4 is 24. X times x squared is x cubed. And y squared just comes down. Okay, so that's the equivalent expression for this one here. All right, let's do the same thing with this one. 1 over 8x cubed y. So let's start with what can we multiply by 8 to get to 24? And that would be 3, right? So multiply by 3. We already have an x cubed here, so we don't need to do anything to that. But we do need to get a y squared, right? And we have a y to the first. So what times y to the first equals y squared? Y to the first, right? Or just y. So we're going to multiply by 3y on top and bottom. And on top, 1 times 3y is just 3y. On the bottom, it'll be 3 times 8 is 24. X cubed comes over, and y times y is y squared. So we get the same thing, right, that we needed. All right, and last but not least, we have 3 over 4y squared. So we're going to ask ourselves the same questions. What can we multiply by 4 to get to 24? It'd be 6, so I'll multiply by 6. And then I don't have any x's, so I need to multiply by x cubed to get all 3 of those x's. And then I have a y squared already, right? So I don't need any y's. So whatever I do to the bottom, I'm going to do the same thing to the top. So remember, we're just multiplying by 1, right? Anything over itself is 1. And so if we multiply by 1, we're keeping the same value, but we're just changing the appearance. So on top, 3 times 6x is going to be, or 6x cubed. 3 times 6 is 18, x cubed comes over. On the bottom, we kind of know what we're going to end up with, right? But let's just double check. 6 times 4 is 24, x cubed, and then y squared, okay? So those are our equivalent expressions with the common denominator.